Hello, my dear children. Are you ready to listen the class? Now come to the question number 4 in exercise 1.2. Show that the modulus function f from R to R given by f of x is equal to mod x is neither 1 1 nor on 2, where mod x is x if x is positive or 0 and mod x is equal minus x if x is negative. Okay, my dear children, understood the question. What is the function here? Modulus function. What is the function here? F. What is the domain here? Real numbers, set of real numbers. What is the codomain? Set of real numbers. Okay. What is defined as f of x? F of x is equal to mod x. Okay, my dear children. Right. Now come to the solution part. First of all, we write the given data. What is given here? F is a mapping from R to R and f of x is equal to mod x, where mod x is equal to x if x is greater than or equal to 0 and mod x is equal to minus x if x is less than 0. This is the given data for us. Okay, my dear children, what is the function here? F. What is the domain here? R, set of real numbers. What is the codomain here? Set of real numbers. Okay, my dear children, what is f of x? Mod x. Okay, now we are verifying. Now we are going to show that this function is not 1 1 function. Okay, my dear children, see here we know that modulus of minus 1 is equal to 1. That is f of minus 1 is equal to 1. Similarly, f of 1 is equal to modulus of 1, that is equal to 1. Here I have chosen two different elements in the domain. What are the two different elements? Minus 1 and 1. And I found their images. What are the images we got here? 1 and 1 only. So here f of minus 1 is equal to f of 1. Images are equal. Whereas the two elements in the domain are distinct. It means the function is not satisfying the 1 1 function condition. Distinct elements in the domain should have distinct images in the codomain, but it is not satisfied here. Therefore, we can say that f is not 1 1 function. Understood, my dear children? Right. Now, I am representing this data in the following arrow diagram. See here, domain R. Here, codomain is also R. The function is f. I have written some elements in the domain minus 1, 0, 1, 2 and so on. Here in the codomain also I wrote some elements and so on minus 1, 0, 1, 2, 3. So here the image of minus 1 is 1. The image of 1 is also 1. So distinct elements in the domain are chosen here, but their images are not distinct. They are same. So we can say that f is not 1 1 function. Understood, my dear children? Now come to the next part, that is onto function. Okay, now consider minus 1 belongs to R. I am choosing an element from the codomain, namely minus 1 belongs to R. Now we know that f of x is equal to mod x is always a non-negative real number. Do you know this definition? Modulus of x value is always a non-negative real number. Thus, there does not exist any element x in the domain such that f of x is equal to mod x, that is equal to minus 1. So here we are not unable to find the pre-image of minus 1. It is in the codomain. We cannot find the pre-image of this minus 1 in the domain. That is why we can say that f is not onto. Here the modulus function r from R to R is neither 1 1 nor onto. Okay, my dear children, it is proved now here. Now come to the next question, question number 8. Okay, now my dear children, let A and B be two sets. Show that F is a mapping from A cross B to B cross A such that F of A comma B is equal to ordered pair B comma A is a bijective function. Understood this question, my dear children? Here A and B are two sets. This is the given data for us, and F is a mapping. What is the function here? F. What is the domain here? A cross B. What is the codomain here? B cross A. Okay, my dear children. How f is defined? F of A comma B is equal to ordered pair B comma A. Okay, my dear children, now we are going to show that this function is a bijective function. Right. Now come to the solution part. First of all, we write the given data. What is given here? A and B are two sets, and F is a mapping from A cross B to B cross A, and F of A comma B is equal to ordered pair B comma A. Okay, this is the given data for us. Now, one function. Okay, my dear children, we are going to show that the given function is one function. You know the steps. What are the steps? You have to select any two elements from the domain. So I have selected ordered pair A1 comma B1 comma ordered pair A2 comma B2 belongs to A cross B. From the domain we have selected two elements, namely A1 comma B1 ordered pair and ordered pair A2 comma B2, and we have to consider f of A1 comma B1 is equal to f of A2 comma B2. I said many times, these are very important steps. These two steps are very important to prove that given function is one function. Okay, my dear children, this implies ordered pair B1 comma A1 in LHS we write. In RHS ordered pair B2 comma A2 because f of A comma B is equal to ordered pair B comma A. If f of A comma B is equal to ordered pair B comma A, what is f of A1 comma B1? Ordered pair B1 comma A1. So I wrote it in LHS. Similarly, f of A2 comma B2 is equal to ordered pair B2 comma A2. So I wrote it in RHS. Understood, my dear children? This step, right? There is a property. What is the property? If two ordered pairs are equal, then corresponding first components are equal and corresponding second components are also equal. Okay, by using this property, we get here, this implies B1 is equal to B2 and A1 is equal to A2. By using that property, we get this step. Understood with this step, my dear children? This implies ordered pair A1 comma B1 is equal to ordered pair A2 comma B2. Okay, my dear children, can we write this step by using this property or not? Yes. Okay, my dear children. Okay, so we have started as f of a1 comma b1 is equal to f of a2 comma b2, and finally we got here ordered pair a1 comma b1 is equal to ordered pair a2 comma b2. It means the given function is satisfying the one function condition. Therefore, we can say that f is a one function. Understood, my dear children? Yes. Now we are going to prove that given function is an onto function. So we have to select an element. Ordered pair B comma A belongs to B cross A. From the codomain, we are choosing an element from the codomain, and we prove that it has a pre-image in the domain. That is enough to prove the given function is onto. Every element in the codomain should have at least one pre-image, at least one inverse image in the domain. Okay, my dear children. So then there exists an ordered pair A comma B belongs to A cross B, that is in the domain, such that f of A comma B is equal to ordered pair B comma A, because this is the definition. Okay, my dear children. So if there is an element in the codomain ordered pair B comma A, then its preimage, what its preimage? A comma B should be there in the domain. It is satisfied by the given function. Okay, my dear children, right? Therefore, here the function f is satisfying the onto function condition. That is why we can say that f is an onto function. So here f is one function as well as onto function. Hence, we can say that f is a bijective function. Understood, my dear children? Right.